In this video, we'll prove a complex differentiation identity step by step. Let's start by looking at our problem. Let's break this down step by step. We start with our given equation, y equals x squared minus 1 raised to the power n. Now, let's find the first derivative. Using the chain rule, we multiply by the power n, reduce the power by 1, and multiply by the derivative of the inner function. This gives us y sub 1 equals n times x squared minus 1 to the power n minus 1 times 2x. We can simplify this expression. By rearranging, we get y sub 1 equals 2x n times x squared minus 1 to the n divided by x squared minus 1. From this, we can multiply both sides by x squared minus 1 to get x squared minus 1 times y sub 1 equals 2xny. Now for the second derivative. When we differentiate again, we need to use the product rule, since we have a product of terms. This gives us x squared minus 1 times y sub 2 plus y sub 1 times 2x equals 2n times x y sub 1 plus y. Let's rearrange this equation. Moving all terms to the left side, we get x squared minus 1 times y sub 2 plus 2x y sub 1 minus 2 and x y sub 1 minus 2 and y equals 0. Now we can factor out common terms. The terms with y sub 1 can be combined, giving us x squared minus 1 times y sub 2 minus 2x y sub 1 times n minus 1 minus 2 and y equals 0. And finally, we can write this as x squared minus 1 times y sub 2 minus 2 times n minus 1 times x y sub 1 minus 2 and y equals 0, which is what we wanted to prove. This completes our proof. We started with y equals x squared minus 1 to the n, took two derivatives, and through algebraic manipulation proved the required identity.